now we are going to start our next chapter, that is bit manipulation. Now in this chapter we are going to learn some algorithms and some techniques by which we can perform our operations on bitwise level. So what is bit manipulation, or before we dive into bit manipulation we need to understand one number system, that is binary number system. Binary number system. So binary number system consists of only two numbers, that is either 0 or 1. So whatever the information we have in our computers, in our phones, in our tablets, AirPods, whatever, that is stored in the form of binary numbers, combination of some binary numbers, that is zeros and ones. Well, in max we have decimal number systems, right? In max we have decimal number system. So what are decimal number systems, or what are the numbers we have? Unique numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the unique numbers, and by combining these all 10 numbers, that is totally 10, right? That's why we call it as decimal number system, DEC. DEC means 10. So these are the 10 unique numbers, and by the combination of these 10 numbers we can write whatever the number we want. Suppose if we want to write 980, then I can write 980. So here 9 is a unique number, 8 is a unique number, and 0 is a unique number. Similarly, this is how we are the things, this is how we can store information in our real world by using mathematical description, that is decimal number system. So when it comes to computers, our computers store information, whether it may be our photo, whether it may be our data, whether it may be our file, and we are coding, right? Whatever the coding we are doing, that gets stored in our computer in the form of binary number combinations. Binary number combinations. So of combination of zeros comma ones, that is nothing but information. So our computer stores numbers in the form of binary number system. So this is the basic of binary number system. Now let us see, so our computer stored all the memory, all the information, all the data in binary number system, right? So we need to understand how we can calculate or convert from binary number system to decimal number system, or from decimal to binary. Now let us see that I told you now that whatever the information we have is stored in the form of zeros and ones. So information is a combination of zeros and ones, and this is known as binary number system. So let us see how we can convert our decimal numbers to binary numbers, or binary numbers to decimal numbers. So whatever the information, suppose if I am storing my name is Jabir, then this information is converted into binary number system and stored in our computer. So our computer language is binary number system, right? So binary in our computer stores all the things, all the information in binary number system form, right? So binary numbers are 0 and 1, that's all, right? Okay, our memory, our computer store all the information in binary number system. So whatever the code I have provided, or whatever the information I have provided, that will convert into binary numbers. After that will get stored in our computer. So this is how information storing works. Now in this we are not going to see how the conversion takes place, how the each character get converted into binary number, right? Just in this chapter we are going to see just a little basic how we can convert a decimal number system to binary, and a binary number system to decimal. So let us consider that 0, 1 is a binary number. So we will represent a binary number like this, and suppose 4 is a decimal number, right? So we will represent a decimal number like this. So this is the representation of binary number, and this is the number of representation of decimal number. So this is how we will represent a binary number and a decimal number. Now let us see how we can convert a particular decimal number value or a binary value to decimal, or that respective binary. Now this is how we can convert. This is the main fundamental things that we are going. There are some fundamental things that we have to perform to convert decimal to binary and binary to decimal. So let us consider that the given value is 4. That given decimal value is 4, and we need to find its conversion in binary form. So what we do in high school, we studied LCM, right? So what we do, just we will divide it with 2. So to convert a decimal number to binary number, we just divide it 2 and we will store its remainder. So 2 ja 2 ja 4, and the remainder is 0. After 2 1 ja 1, 2 1 ja 2, after remainder is 0, and finally whatever the value we got, that is the remainder, right? So this is my remainder. So from lower to top, this is my binary number. So 4, can I write that 4 in decimal is equals to 001 of, sorry, 4 in decimal is equals to from top to down. This is my binary number, that is 100. This is my decimal form. So 4 in decimal is equals to 100 in binary. So this is how we will convert a particular given number, given by a decimal number, to binary conversion. Suppose let us take our user has given us 6, then the binary form of it 6 is 2 3 ja, after it remainder is 2, after 2 1 ja, remainder is 1, after that finally 1. So the order is 110 of binary is equals to 6 of decimal. So this is the conversion of 6 from binary to decimal. This is how we will convert a particular given number from decimal to binary. See, this is the conversion or the logic behind it. Now let us see how we can convert a binary number to decimal number. So this is our given example, that is 100. So the main fundamental or the main logic we are going to use to convert a particular given binary number system into decimal number system is, we'll multiply that particular unit or decimal into 2 to the power of 0, 2 to the power of 1, 2 to the power of 0, 2, like this. Suppose this is my first digit, right? So we'll come from right to left. So I will multiply it 2 to the power of 0, plus I will add after 2 to the power of into 2 to the power of 1 plus 2 to the power of 2. So this will give me 4, after this will give me 0, after this will give me 0, right? So this is my decimal number. So can I write that 100 of decimal is equals to 4 of 10? Suppose the given number is 110. Suppose the given number is 110, then I will multiply 0 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 1 into 2 square. That will give me 4 plus 2 plus 0. This will give me 6. So can I write that 110 of decimal binary is equals to 6 of decimal. So this is how we will convert from binary to decimal. For binary to decimal, what we do, will take the binary number and multiply it with 2 to the power of 0, each digit with 2 to the power of 0, after next digit 2 to the power of 1, after next digit that consecutive 2 to the power of 2, and the 2 to the power of n increases after each digit as the digit increases. So this is how we will convert a particular binary number to decimal number. To convert a decimal to binary, we will do LCM. We will perform LCM and we will take its remainder, right? And from bottom to top, that is our decimal number. So this is the logic for converting a particular given number from binary to decimal and decimal to binary. I hope you have got the logic. Now let us dive into bit manipulation operators. There are some operators which we are going to study in detail with examples, and we are going to study how they behave or what are the rules that we have to perform binary and binary OR. So in bitwise operator, there are some operators like binary AND, binary OR, binary XOR, binary ones complement, binary left shift and right shift. So we are going to study in detail and understand what are the binary and what is binary OR, what is one's complement, left shift and right shift in detail, and what are the rules for it. Now let us start with what is binary AND. So binary AND is a bitwise operator. So in previous classes we studied logical operator, arithmetic operator. Similarly, when we are going to do some operations in bitwise level, that is in the level of ones and zeros in computer language, we use bitwise operators. So by using bitwise operator, we can manipulate our data, we can manipulate the things which are given by our user in bitwise level, that is in zeros and ones level. We can manipulate that particular data using bitwise operators. Now let us study binary AND. So in max we already know that 1 plus 2, this is a addition operator, this is a addition operator, and 1 minus 2, this is a subtraction operator. So subtraction or addition operators will define what is the operation that gonna take place between two operands. These are the two operands, right? In first chapter I think we studied what is operand, what is operator, and all those things that we are going to use here in our chapter, in our bit manipulation chapter. So this is the operator and these two things are operands. So operator will give me what are the things I am going to perform, what are the things I am going to take such that I will perform some operations on the operands. So binary AND, there are some rules for binary AND. So binary AND represented with a single AND. If I write two ANDs, then it will become logical AND. So we already studied logical operators, right? So binary and is represented by is represented by single and percent symbol, right? The rules for binary, you have to remember the rules for each operator, right? Bitwise operator. So remember guys that the information is stored in zeros and ones, right? So if the first number is 0 and the second number, and we are doing and binary and with the second number is 0, then the output we will get is 0. If the first number is 1 and we are performing and bitwise and after the second number is 0, then the output will be 0. If the first number is 0 and the second number is 1, then the output will be 0. If both the given numbers are 1, then 1 binary and 1 will give me 1. So this is the logic and or the rules for binary and. So remember guys that if and only if both numbers are 1 1, then the output I will get is 1. In another scenario, if any one of the given number is 0, then the output will be 0. So this is the logic for binary and. Let us see an example that the given number is a is equals to 5 and b is equals to 6. So before we perform operations and on by bitwise operators and all those things, I want to tell you one thing that we already studied how to convert a particular decimal number system to binary and binary to decimal. I want you guys to remember or by heart at least 8 values of decimal to binary. So I am going to write here from 0 to 8 values, and I want you guys to remember those values. So for 0, we will write 0 in decimal is equal to 0 0 0 in binary. After it for 1 in decimal, the binary conversion is 0 0 1. After it for 2, the binary conversion is 0 1 0. After it for 3, 0 1 1. After it for 4, the conversion is 100. For 5 is 101. For 6, 110. After for 7, 111. For 8, 1000. So this is the conversion between the decimal from 0 to 8, 0 to 8 in binary form. I want you guys to remember the things, the conversion, the values of conversion, because it will become easy when we are going to do questions of a bitwise and bitwise or and all those things. So it will become easy when it comes to question solving, and I want you guys to remember these things from at least 0 to 8 numbers, decimal numbers, and its conversion in binary. And I want to, before we dive into the bitwise and, I want to tell you one thing, that is here uh, right, 0001 is 1 in decimal, right? So in computer there are not only two zeros, they are like many zeros. Our computer stores many zeros in front of 1. It doesn't matter. Suppose let us take 2, that is 010. We are writing 010. This is not the exact number of 2. Our computer will store like many zeros in front of it, right? But these zeros which are in front of 1 doesn't matter, because we are going to multiply it 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and finally the answer we'll get is 2 to the power of 0 plus 2 to the power of 1 into 1, and similarly and so on. These zeros will give me 0, right? So these doesn't matter. So whatever the computer will store as many zeros as it wants in front of 1, but these doesn't count, these doesn't change the value of 2. I want to tell you one thing, right? This is the thing I want to tell you, right? And the first one we got is known as set bit. I want you guys to remember the technical language. The first one we got, or the first thing from which our number starts to matter. So suppose I am writing like 1000 zeros in front of it, but the whole decimal value of that particular number doesn't change, because how many zeros we want we can write, but that doesn't change my decimal value. If I write here 0, then on the right side of my 1, if I write another 0, then that particular thing matters. Because first of all I got my set bit. From set bit, whatever the things we are writing 101, that thing starts to matter. So what is set bit? Set bit is the first digit or the first unit from which the number starts to get matter. If I change any number from the right side or right side of my set bit, then everything will get changed. The decimal value of it change, or the data will change. Whatever the whatever the things I want to change, I can change on the right side. I can add as many zeros left side of my set bit. I can add as many things as I want, but those things doesn't matter because the data is not changing. So this is the concept of set bit, and I want to remember at least, I want you guys to remember at least 0 to 8 digits of decimal from binary to decimal and decimal to binary. Now let us dive into our question, that is AND. So we already know that the value of A is equals to 5 and the value of B is equals to 6. So let me write its binary form, that is A is equals to 1 0 1 0 1, after that B is equals to 0 1 1 0. Now I am performing AND. So let me write clearly here 1 0 1 0 1 1 0. I am performing AND here. I am performing AND here. So what I told you, this is the rule. This is the rules for bitwise AND operator. Bitwise AND operator, these are the rules. So here the first number is 1 and the second number is 0. So if any one of these things are 0, then what I will get? I will get 0. Here the same value, the first thing is 0 and the second thing is 1, so I will get output as 0. After that 1 1, if both are 1, what I will get? I will get 1 as my output. After that 0. So this is in decimal, the value of this is 2 to the power of 0 plus 2 to the power of 1 plus 2 square into 1 into 0 into 0. The value of is 10. So can I write that 0 1 0 0 of decimal, the answer I got is equals to 4 in decimal. So if I do 5 and 6, it will give me answer of 4. If I perform 5 plus 6, this will give me answer of 11. So similarly, if I perform 5 binary and 6, that will give me answer as 4. Now let us code this thing and understand. So this is my main program, public class Java basics. In that, my main program was public static void main string args. Now I am going to create int a is equals to 5. After that, int b is equals to 6. And whatever the value I got, 5 and that is a and 6, a and b, that value I am going to print. Now let me save this and run. You can see that the value I got is 4. So I am doing 5 and 6, that will give me the value of 4. So this is how binary AND works. Now let us talk about binary OR. So the rule for binary, the binary OR is represented by a single pipe like this. So if I write two pipes, two single pipes, then it will give me logical OR. Right? If I write single pipe, then it will give me binary OR. Binary OR. So this is the, you can see that on the above of enter button, you can find that particular single pipe button, right? I don't know what we call it, I call it as single pipe, right? Okay, so the rules for binary OR is, first of all, suppose if the first number is 0 and we are performing OR binary OR operator and the second number is also 0, then I will get output as 0, right? If the first number is 1 and we are performing OR and the second number is 0, then it will give me 1. If the first number is 0 and we are performing OR and the second number is 1, then I will get output as 1. If both are 1 and I am performing binary OR, then it will give me 1. So this is the logic. So if any one of the given numbers is 1, then I will get output as 1. If both are 0, then and only I will get output as 0. So you can also demonstrate or imagine these things as if let us consider that 0 as negative and 1 as positive. So if negative plus negative will become, if negative person meets a negative person, then the output will be negative. If a positive person meets a positive negative person, if a positive person meets a negative person, then the end results will be positive, right? If the negative person meets a positive person, then also our output will be positive, right? If both are positive, then we will get again lot of positiveness, right? So we will get a positive number. So this is the logic, or you can understand by this way. So this is how binary OR works. Now let us perform the binary OR for this operator, right? So a is equals to 5, that is 0 1 0 1, and b is equals to, b is equals to 6. Can I write in binary form 1 1 0 0 1 1 0? Now we are performing A or P. That is, I can write 0 1 0 1, after 0 1 1 0, and we are performing binary OR in this. So we already know that if any one of them is 1, then we will get output as 1. So 1 1 1 0. So this will give me 2 to the power of 0 into 1 plus 2 after 2 square, that is 4. So it will give me 4 plus 2 plus 1. So this will give me 7 as my output. So if I perform 5 or 6, this will give me output as 7. Now let us put this. Now here we have taken int a is equals to 5 and int b is equals to 6, and we are performing OR here. Binary OR. Save this a or b and save this thing and run. You can see that we got our output as 7. So this is how we can this is how the OR or binary OR operator works. Now let us talk about binary OR. So binary OR is represented by this symbol. You can find this on top of, I think, 6, on top of 6 button. You have to press shift and 6, so this will give me this button, right? Okay. Now the rule for binary OR is represented by this symbol. So if I am performing OR operator in the rules for binary OR is 0 OR 0. This will give me 0, right? If any one of the numbers, suppose the first number is 1 and I am performing OR with 0, then this will give me 1. So if the first number is 0 and I am performing 1, then the output will be 1, right? If the first number is 1 and the second number is also 1 and I am performing OR operator on this, then the output will be 0. So this is the logic for OR operator. These are the rules for OR operator. Remember guys that if any one of the given number is contains two different number, that is the first number and second number is different, then only I will get output as 1. If both are same, then I will get output as 0. So this is the logic for OR operator. So let us see that the given values a is equals to 5, that is 0 1 0 1, and b is equals to 6, that is 0 1 1 0, and I am performing OR operator on this, that is a OR b. So let us see what the output will get. 0 1 0 1 OR 0 1 1 0. So the two numbers are different. If different, then I will get output as 1. After here also different, so I will get output as 1. Here same, so it will be 0. After it same, 0. So this will give me 1 and this will give me 2, and adding this will give me 3 in decimal. So can I write that a OR b, that is 5 OR 6, that is nothing but in binary 0 1 0 OR 0 1 1 0. This will give me 0 0 1 1. That is nothing but in decimal. This is a 3 to the 3 in decimal, 3 value in decimal. So if I do 5 or 6, this will give me 3 as my output. Now let us see, verify the output. Here I am taking int a is equals to 5. After that int b is equals to 6. After that I am printing the OR value of a and 6. So a OR b. Now let me save this thing and run. You can see that I got my output as 3, and when I did the dry run before, then I got the same output. So this the OR operator works like this way. Now let us talk about binary ones complement. Binary ones complement is represented by this symbol, and in max we used to do represent this for approximately, right? So for approximate value we use this kind of symbol, and in computer language we use binary ones complement for this symbol, right? Okay. Now the binaries are binary ones complement work is it will convert from 0 to 1 or 1 to 0, right? Suppose if the given number is a is equals to 5, right? That is 0 1 0 1. So if I perform OR on this thing, if I perform OR 5, that will convert from zeros to 1s to 0 and zeros to 1. So 1 will be converted into 0 and 0 will be converted into 1. After it 0, after it 1. So this will give me output as 0 plus 2 plus 0 plus 0 to the power of 0 to the power of 1, 2 square, 2 cube. So this will give me 2 to the 4, 4 to the 8 plus 2. So this will give me 10 as my output. So this is the concept of OR. So the concept of OR is it will convert the numbers from, if the binary number is 1, then it will convert into 0, and if the binary number is 0, then it will convert into 1. After that 1, then 0 0 1. So this is how binary ones complement works. Now I want to tell you one thing, that we already seen that binary 5, that is by ones complement 5, this is giving me output as 1 0 1 0. Let me convert it into decimal, that is 2 to the power of 0 into 0 plus 2 to the power of 1 into 1 plus 0 plus 2 cube, right? 1 0 1, 2, 3, yeah, 2 cube plus into 1, right? So this will give me 2 to the 4, 4 to the 8 plus 2. So this should give me 10. So binary 1's complement should give me 10 as my output. Now if I run the code, first of all I will run the code and show you, and if I run the code, then the output is not same. I will not get 10. Let us see why. Before that, let us code this thing. So here I am taking int a equals to 5. After that I am printing its complement, that is a complement of 5, nothing but a. Now let me save this thing, and by our manually we run a dry run on my binary one's complement, right? When I did the dry run, I got my output as 10. So if I run this code, then let us see what the output I will get here, right? You can see that I got my output as minus 6. So why I got minus 6? So binary ones complement will convert ones into zeros and zeros into ones, and when I did the dry run, it will give me I got the output as 10. But here I got, when I actually run the code, I got my output as minus 6. Why this happened, or what are the things that are going on? So to understand that, let us consider our number. So this is my given number, right? 0 1 0 1. So binaries or will convert this particular number into one. If the binary number is 1, at that particular bit the binary number is 1, then it will get converted into 0. If it is 0, then it will get converted into 1. So this is the work of binary ones complement, right? And I told you one thing, that our computer doesn't store number like this. It will store like suppose this is not the actual number in our computer, that is 0 1 0, and it will store like thousands, even millions of zeros in front of it, like 0 0 0 0 0. So when I apply, this is the actual number I will get in my computer. This is the actual number which our computer actually stores, and we represent that particular number in the short form like this. So when I do the complement, then all the zeros in front of it gets converted into 1, that is 1 1 1 1 1, after it 0, after it 1, after it 0. So when I do the complement of these value give me a huge value, huge positive value, because they are like a lot of zeros, thousands of zeros, right? Suppose they are like 10,000 zeros or 1,000 zeros, then 2 to the power of 1,000 into 1. So this will give me a huge value, and I need to add with 2 to the power of 999 into 1 plus 2 to the power of 998 and so on up to 2 to the power of 1 with the zeros and the combination of ones, right? So this will give me a huge value, and these thing, let me write here 0 0 0 0 0 1 0 1. So this thing is known as most significant bit, and this thing is known as least significant bit. So when I did the ones complement, right, I got the output as minus 6, because when I do the complement, the values I will get are huge. So because of most significant bit, you don't need to go into deep dive what is happening in computer system, what are the operations that get performed in our computer. You just have to remember that these things, we got minus 6 as our output, this is because of most significant bit. Because of most significant bit, our what one's complement will do, we got the negative number, right? So the negative number we got because of 2's complement. So what is 2's complement? 2's complement is nothing but our computer will perform 1's complement on a particular given number. Let us consider that this is my given number and it will add 1. So when the computer add 1's, this thing is known as 2's complement, and because of 2's complement we got our output as a negative value. So this is the concept of binary ones complement. So when I do a particular number complement, I will get a negative value, right? Whatever the negative value may differ, but this is due to most significant bit and 2's complement. So when someone asks you, someone might like interviewer ask you, like when I do the when I do the ones complement of a particular number, it is giving me negative number. Why? So the answer is because of first thing, most significant bit, like there are like thousands of zeros in front of a particular number, and this is my set bit, right? So in front of set bit there are like thousands of zeros. So these thousands of zeros will converted into ones. So when I do ones complement, those thousands of zeros will convert it into ones. So because of most significant bit and 2's complement, by combining these two things, we got our output as negative. So this is the reason, because of 2's complement and most significant bit. Because of these two concepts, I got my output as -6. So this is the concept of binary ones complement. Now let us talk about binary left shift. So I used to remember this binary left shift and binary right shift. There might be a little confusion for binary left shift or binary right shift symbols when it comes to symbols. So remember guys that I use this trick and I am recommending you to. It is so this is my peak. I consider that this is my ducks or birds peak. So the peak, wherever it will come on, if the peak came on the left side, then it is known as binary left shift. If the peak came on the right side, then it is known as binary right shift. So this is the symbols that are used to represent binary right shift and binary left shift. So the concept of binary right shift and binary left shift is suppose let us take here the number which is given is a is equals to 5. So its conversion is let me write the conversion as like this. So 0 0 0 1 0 1, right? This is my conversion of 5, right? Okay, now when I give 5 left shift 2, then what it means that take the left elements and delete and do the left shift of that particular number. So these two digits, this is my right 5, right? 0 0 0 1 0 0. I will take the first two digits on the left side and I will delete those things and I will push this number towards the left side. So how many digits are there? 1 2 3 4 5 6. Let me write here 1 2 3 4 5 6. So I will push this particular number to my left side. So the value will become 0 1 0 0, and at the last I will add 2 zeros. So this is binary left shift works. So this is the value, right? 0 0 0 1 0 1. So I want to, if I write binary left shift 3, then I will take the first 3 digits and I will delete it. So they are like 6 digits, right? 1 2 3 4 5 6, and I will take these 3 and I will put it in the front, that is 1 0 1, and I will put 0 0 0. So this is my answer. So this is the answer I will get for binary left shift 3. This is the answer I will get. So there is a formula for calculating binary left shift, that is a left shift b is equals to, the in decimal format the answer is 2 cross a cross 2 to the power of b. So this is the formula. So when we are in competitive coding, you might use this formula. So remember, note down in your book that this is the formula for binary left shift. So suppose the binary left shift 2 is binary left shift 2 is equals to 5 into 2 to the power of b, that is 2 square. So this will give me 5 into 4, the answer will be 20. So if I do binary left shift 2, then it will give me answer as 20 in my decimal format. Now let us code this thing. So let me take here int a is equals to 5. After that I am printing here system.out.print 5 binary left shift 2, that is nothing but a binary left shift 2, and we already did the error, and let me run this. The answer I will get is 20, right? So let me see. Yeah, we got our answer as 20. So this is how the concept of binary left shift. So we will take the left numbers at my given binary number, and we will delete the n numbers, that is binary left shift b, right? That is a left shift b. So we will delete b digits on the left side of my given binary number. So this is how binary left shift works. Now let us talk about binary right shift. So this is very similar to binary left shift. So in binary left shift was what we used to do. We'll take the left digits of that particular given binary number, and we'll take certain digits of that particular binary number, and we'll delete those, and I will push the number towards the right. So here, instead of pushing right, I will take the right side numbers and delete those, and I will push towards the right side of my right side. So this is the concept of binary right shift. So let us consider that this is my given number, that is a is equals to 6. A is equals to 6 in binary form 0 0 0 1 1 0. So if I want to push it towards the right side, then what I will do, right? this is the right shift, right? So I will take the number, given binary number, that is 000 110, and I am doing right shift 1. So how many digits are there? 1 2 3 4 5 6. So I will take the last digit and I will delete this number, and I will push towards right. So the output will be here 1 1 0 0 0, and I will add 0. So suppose if I want to write like, consider that the given number is 0 0 0 1 0 1 0 0. So suppose if I want to do the right shift for these two numbers, then how many numbers are there, how many digits are there? 1 2 3 4 5 6 7 8. So I will take these two digits number and I will delete. So how many digits? 1 2 3 4 5 6 7 8. So I will delete this and I will push this number towards the right, that is 1 0 1, and I will add 0 on towards the right side of my number. So this is how binary right shift works. So what output this will give me? This will give me as a 2 to the power of 0 plus 2 to the power of 2. So this will give me output as 3 in decimal. So 6 left shift left, right shift 1 should give me output as 3 in my decimal number format. Now this is the concept of binary right shift. So we are just pushing the given number towards the right by deleting the given n digits of my binary number. So this is how bit manipulation of right shift works. Now in the place of a is equals to 5, I am giving as 6. I am giving 6. After that here, what I am doing? I am doing a right shift 1. Right. So if I run this code, I should get my output as 3. Now let me see. You can see that I got my output as 3. So this is how binary right shift and binary left shifts work. Now let us dive into questions and let us see how we can solve our real world questions or basic questions using bit manipulations technique. Now in the given question we have to find out whether the given number is even or odd. So in this question we have to find out that user will give us a n number, and we have to find that whether the given number is even or odd. So what is the logic? And here we already know that for finding particular number is even or odd, what we'll do? We will do n modulo 2. If it is 0, then it is even. If not, then it is odd. So we already know the concept of finding even or odd. Now in this we are not gonna use modulo operator. This is the catch here. In this we need to use the binary operations that we have studied. The bitwise operators we are going to use in this question. Now let us see. First of all, before we dive into question, before we dive into the coding part and all those things, first of all let us observe one thing. I am going to write numbers from 0 to 5. Let us consider, right? So the 0 number, can I write 0 in decimal is equals to 000. 1 in decimal is equals to 001. 2 in decimal is 010. 3 in decimal is 011. After that 4 in decimal is 100. 5 in decimal is 101. Right, these are the conversion of decimal numbers into binary numbers. Now can you observe one thing here? Can you able to observe one thing, that for odd numbers the least significant bit, that is least significant bit is 1 here, right? For 1 is odd number, such that the least significant bit is 1. 3 is odd number, least significant bit 1. For 5 is a odd number, so the least significant bit is 1. So can I write that if my least significant bit is equals to 1, then the given number is a odd number, right? If it is 0, then the given number, if it is 0, then the given number is a even number. So what I need to do, I need to find my least significant bit of my given number. Right? How we can do this? How we can calculate the least significant bit of the given number? Right? Let us observe one thing. Let us do trial and error method, and let us come up with a logic here. Now let us consider that the given number is n, and here let me use binary AND operator. Right? So the binary AND operator, what it will tell me, that the given number is 0 and we are performing AND 0, then the output will be 0. If both are 1, If both are 1, then and only our output will get 1. In all other cases, we'll get output as 0. So this is the concept of binary AND. Now let us see that this is my given number and I am performing AND operator to 0. So what it will give me, if I perform n and 0, then it will give me 0 for my whole number. Whatever the number may be, it will give me 0 because the given number is 0, right? So if the given number is 0 and whatever the number here we will get, if the given number here is 0, then I will get output as 0. So if I perform n and binary and 0, so this will give me 0 or output always everywhere. Now if I do that n modulo sorry n binary and 1, so if this thing give me 0, by chance if this thing give me 0, then the given number is even number, right? After that, here if the given value I got as 1, then the given value is odd number. So let me explain this first of all. Let us take 3 as my output. So 3, right? 3, the binary number conversion is 0, 1, 1. And 1, here I am doing AND for 1, right? So 1 conversion is 0, 0, 1. And I am performing AND in between them, 0, 1, 1 and 0, 0, 1. So if the given number, here you can see that 1 and 1, it will give me 1, and 1 and 0, it will give me 0, and 0, 0, it will give me 0. You can see that the least significant bit here is 1. So if what I told you, that if my least significant bit is 1, then the given number is odd number. If it is 0, then the given number is even number. So here can I write that my end and 1 is equals to it will give me 1, this is 1, right? So this is 1 in decimal. So if it will give me 1, if it give me 1, then the given number is odd, else the given number is even. So this is the logic for finding the given number is even or odd using bitwise operators. So here let me write my function public static static void type function. So it will tell me the given whether the given provided number is even or odd. So after it I am going to write my function name, that is even or odd. Here I will pass my n value int n. After it, in this I have to store the value of 1 because I am doing n and 1, binary and 1. So for this I am going to create my variable, that is bitmask is equals to 1. I am going to create my bitmask is equals to, I am going to store that value as 1. After it, what I will do if n and bitmask is equals to 1, then system.out.print the given number is a odd number, else given number, sorry I have to print here, right? Okay, system.out.print given number is a even number, right? That's all. Now here let me give int n is equals to 10. After it I am calling my function, that is even or odd function, and I am passing the value of n. Now let me save this thing and run. Here it is showing me some error. Now let me let me give some brackets and syntax for my code. Yeah, yep, that's all. Yeah, now save this thing and run. You can see that the given number is an even number. So here n is equals to 10 is an even number, right? Now I am passing n is equals to 11. Now let me save this thing and again run. You can see that I got my output as given number is an odd number. So this is how we can calculate that whether the given number is even or odd using bitwise operators. Here we didn't use modulo operator or division or anything normal things we used to do, right? Here we just write n and bitmask. Bitmask is equals to 1, right? N and bitmask. If it is 1, then simply print even number, that is odd number, else print even number. So this is the logic using bitwise operators. Now let us study some operations that we will perform in bitwise operator, right? And that is get ith bit, set ith bit, and clear ith bit. So these are the three operations that we generally perform in when it comes to bit manipulation chapter, right? Suppose let us consider that the given number is 0, 0, 0, 1, 1, 1, right? This is my zeroth index, first index, second index, third index, 4, 5, 4, 5, right? Suppose if I want to change the value which is present at or if I want to get the value which is present at my second index, that is if I want to print the second index bit, that is 1 to my user, then I will use get ith bit function. So what is the logic for get ith bit function? The logic here is we will use the same thing, and bitwise and. In the previous question, what we used to do, we did bit mask is equals to 1, that is 0, 0, 1, right? 0, 0, 0, 1, and we put our value of 1, that is set bit at LSB, that is least significant bit. So the 1 is that is set bit is at least significant bit. Now to find the get ith bit, will left shift our value. So what I told you, that we will push our one value or whatever the data we have in bitwise operator, left shift is used to push the particular given number at ith bit. Suppose if I want to push like this one number bit mask from for like two digits, then I will write 2, right? Suppose if I want to push this one value towards the binary conversion of this 2 value, binary conversion of 1 from 3 digits, then I will write 1 3. So this will give me 0 0 1 0 0, and this will give me 0 0 1 0 0 0. So this will push me 3 bits, and this will push me 2 bits. So suppose if I want to push ith bit, then I can write 1 left shift I. So this will push me I bits, ith bits. This will push. Now I here to get ith bit, I will use binary AND operator. So the logic we are forming here is we will use and left shift, and by combining these two things we will get the ith bit present at that particular index. Now suppose let us see that if I am doing the given number is n, and I am doing bit mask, that is nothing but my 1 left shift I. Now let us see what it will give me. So I already know that, let us consider that 0 0 0 1 1 1, this is my given number. So at I is equals to 2, there are only two values that can be possible, because in binary numbers there are only two values, right? Two numbers are there. So if at I is equals to 0, then at that I is equals to 0th index, there can be possible only two values, that is either 0 or 1. So if the value is a 1, then I will write 1 to my user. If the value is 0, then I will print 0 to my user. So if I perform that 1 and 1, I know that the output will be 1. In this scenario, this is the output. In other scenarios, in other cases, whatever the case may be, if here the value is 0, then I will get value as 0. So what I will do, the code, pseudocode will be, first of all I will write my get ith bit function, here I will get my n value. After that I will create my bit mask is equals to 1. After that here I will also get the ith bit as my output, right? After that, if my n and bit mask of left shift I, if this is 0, then what you will do, you will just return 0, else return 1. So this is the code for getting the ith bit present at that ith index. Now here let me create my function for get ith bit. So I am going to create my function public static int type function, because I am going to return an integer, right? The value which is present at that ith index. After that I am going to write get ith bit. In that I am going to pass my n value, after that my index comma int I, right? After that first of all I am creating my bit mask is equals to 1. After that bit mask is equals to 1. After that, if my n and bit mask of left shift I, if the provided value is 0, if the answer I will get as 0, then I will return 0. Else return 1. So this is the code here. I am going to pass my suppose let us take int n is equals to 2. After that I am calling my get ith bit and I am passing the value of n. After that I am passing value of 2. Now let me save this thing and run, and I am printing whatever the value that will returned by my program. I am printing it here. Yeah, let me print this thing. Now save this thing and run. You can see that the ith bit which is present at that particular index. So the given value is n is equals to 2, and you can write the binary number of that particular number, and you can check that at second index the value which is present is 2. Suppose if I give as 1 here as my output, suppose if I give 1 as my output. Now let me save and run again. So at first index the bit which is present is 1. So this is how we will get the ith bit present at that particular index. Now let us talk about set ith bit. Now let us take an example to understand what is meant by setting ith bit at that particular index. Now let me take an example as 0 0 0 1 2 3 4 zeros, after it 1 0 1 0. So this is my example, and at I is equals to 2 I want to change the value of 0 from 0 to 1. So the output will be 0 1 1 1 0 0 0. So if I want to change the particular ith bit at that particular index, then I will call my function that is set ith bit. So this is the functioning or the working of setting ith bit. So I will set the value of from 0 to 1. So this is the work of set bit. So the logic here is, here I will use bitwise operator, bit mask, and I will left shift I, and whatever the I want 1, right, I want to set 1 as my output. So if the present value is 0 and I am setting 1, then I will get output as 1. If the first value is 1 and the second value is 0, then I will get output as 1. If both are 1, then I need to set value as 1. So this is known as this rule is known as binary OR. So here I will use binary OR operator to set my ith bit at that particular index. Now the pseudo code is, first of all I will write set ith bit. In that I will pass int n comma int I as my parameters. After that I will create my bit mask is equals to 1. After that I will simply return n or bit mask left shift I. So this is the pseudo code for setting the ith bit present in my given number. Now let me write my function for set ith bit. So here I am going to create my function public static int type function, because it will return an integer, right. After that set ith bit. In this I am passing value of n, after that passing value of I. Now here what I am going to do, I am going to write first of all create my bit mask is equals to 1. After that I am going to simply return n or my bit mask left shift I. That's all. So this is the code for setting the ith bit present in my ith index. So if I want to change 0 to 1, then I will use set ith bit function, and in this I am using or and left shift operators to set the ith bit. Now in the place of calling set ith bit, I am calling set ith bit. Now let me save this thing and run. So you can see that I got my output as 2. Now I want to set at suppose the second index, then I will get output as 2 into 2 to the power of around like let me see, yeah. Now save this thing and run. So you can see that we got our output as 6. So this is how the working of set ith bit works. Now let us talk about our final operation, that is clearing ith bit. Suppose let us take our example as 1010, right? Suppose if I want to change the index of my from 1 to 0, then that is nothing but clearing. Suppose here I is equals to 1 and whatever the bit I have to here I want to change it into 0, that is 1000. This thing is known as clearing ith bit. So here to clear ith bit again, I want 0, right? I want 0 as my output, so I will use AND operator. So if I want to get 1, if I want to set the value of 1 at my ith bit, I will use OR. If I want to set 0 or clearing nothing but setting 0, right? So if I want to set 0, then I will use AND operator. So here the pseudocode will be very very similar to my what or setting ith bit, but the only change here is in the place of OR I will put AND. So the pseudocode will be, first of all I will write clear ith bit. In this I will pass my n value, after that my ith index int I. After that here I will write my bit mask is equals to 1. After that I will return. Before writing here I am going to use my ones complement. So I am going to use here 1 left shift I. So this will give me the complement here. The only change here between the set ith bit and clear ith bit is here we will use and sorry or comma left shift. Here we will use and left shift comma complementary, that is nothing but ones complement. So here the int bit mask will become bit mask is equals to ones complement 1 left shift I, right? After that what I will do, I will return n and bit mask. That's all this is the code for calculating my clearing ith bit. Let me create the function for clearing ith bit. Clear ith bit function. So I am going to create public static integer type function, because it will return an integer, right? After that clear ith bit. In this I am passing int n comma int I, right? After that I am going to create my bit mask is equals to complement 1 left shift I. After that I am going to return n and bit mask. That's all. Let me give space here. That's all. This is how I will return my bit mask. Now in the place of set ith bit I am going to call my clear ith bit. And in the place of one index I am passing I is equals to 1. Right, now let me save this thing and run. I will get output as 0, because at first at I is equals to 1 there is 1. If I converted the I1 from 0, then here n is equals to 2, right? So if I clear the set bit, then I will get the output as 0. So this is how the clearing, setting or getting ith bit works. So in this question we will calculate the power of the given number. Suppose let us take a to the power of n. Then how we used to calculate it? Yeah, in our general method we used to run our loop for n times and we will calculate its multiple, that is a dot a dot a dot a dot a dot a up to n times. So this is how we will calculate the power of the given numbers, and we will run a loop for n times. So the time complexity of the given code, the worst case time complexity will be, we are running the loop for n times such that our loop time complexity will become big of n. So in this question we are going to calculate the power of the given number using bitwise operator, and this is going to be a way more efficient code, because we are going to reduce our time complexity from big of n log n. So this is a efficient code rather than running the loop for n times we'll run for loop, or we'll take our code for time complexity big of n log n. Now the concept of, or the intuition for calculating fast exponent quotient, that is nothing but calculating the power of the given quotient. The intuition here is the main logic is, first of all, here the given number is, let us consider a, and we will calculate to the power of n. So we will take its power, we will take n and we will convert it into binary. We will convert it into binary form, and will convert it into binary form, and from the binary we will calculate the power of that particular given number. So in the beginning this question might sound a little bit tricky, a little bit difficult. So if you watch the video again and if you do the question on yourself, by yourself, then you will understand it. Believe me, you will understand the things. Now here we will convert the given number to binary form. So let us take example that the given values a is equals to 3 and b is equals to 5. So we will convert 5 into binary form. So this is the binary form, right? 3 1 0 1. And what we'll do here, we'll multiply the given numbers in the multiples of 2 powers, right? To the multiple of 2, right? Okay. So we'll multiply the given number, that is a square, a to the power of, that is multiple of 2, will multiply the power of the binary form of the number into the given value of a, that is, let us take that 1 1 1. So this is the n value, right? So we will multiply it a square and a cube, and by calculating the values with this corresponding values, and we'll multiply it like this. Like suppose, let me write here that 1 into a into 1 into a square into 1 into a cube. So this thing, that is, sorry, a power 4 here, multiple of 2, right? So this thing will give me the power of my given number. Now let me do a dry run. First of all, let me do a dry run such that you will understand it, what are things that is going on in my fast exponent question. Now let me take that, first of all, in the first iteration the value of a is equals to 3, and I am creating answer variable, answer is equals to 1. So in the first iteration, I am going to assign my answer value. Answer is equals to 3. That is nothing but 1 into a, right? That is 1 into a. Here a is 3. So the answer will become 3. After what I am going to do, I am going to change the value of a. A is equals to a square. That is 3 square. So my answer will become 0. Here n is equals to 101, right? In binary form, the n is equals to 5. That is this value. Now in the second iteration, a is equals to 9 and answer is equals to 3. Here you can see that on the second iteration the bit is 0. Whenever we get a bit 0, then we'll just put answer as the answer as 1. So what I will do, answer is equals to the answer is 3 now. So I got 0 here, I will get 0 here, I get 0 here. So if I get 0, then I will just put here 1. So answer will be 3, and what I am going to do, I am going to square again my a value, that is 9 square. So it will become 81. After it, finally, in the third iteration, a is equals to 81 and here 1. So answer will become, answer is equals to 3 into this a value, that is 81. This will give me 243 and a will get changed to a square, that is 243 sorry 81 whole square, right? And the answer for 3 to the power of 5 is 243, and we got our answer and we will print to my user. So this is how we will calculate the power of the given number. And in this, how many iterations we performed? We performed 3 iterations, whereas in our general method we did performed 5 iterations for calculating 3 to the power of 5. Here we performed 3 iterations. So this is a efficient code. Now let me write the code for this particular question. So I am going to create public static void, sorry, integer type question, integer, right? Integer type function, because it will return the integer, that is power of the given function, int. Here I am going to write fast expo, it's the name of a function. I will take int a comma int n. After that I am creating int answer is equals to 1. After that, while my n is greater than 0, n is greater than 0 if n and 1 is not equals to 0, right? I am checking if the given particular bit is 0 or not. If it is 0, then like put the answer is equals to a into 1. Okay, so if this condition is true, then what I will do, answer is equals to answer into a, answer into a. That's all. After that, after completing if statement, a will get changed into a square, right? That is a into a. After that, my n will be changed to n is equals to n left shift 1. That's all. And finally return my answer. That's all. So in this you can see that first of all I have created my, yeah, answer is equals to 1. After it, I am checking whether my n value is greater than 0 or not. If it is 0, then it will come into my while loop. After it, I am checking if the value is, if the particular given bit is 0, then what I have to do, I have to multiply it with a. After it, I increase the value of a. That is, a is equals to a square. After it, you have to move the bit. You have to move towards the left bit. So to move the bit, I am using ith bit, that is left shift. So this is how the working of my question, this is how the functioning of my question is. Now finally I am calculating the answer and finally returning the answer to my user. Now let me give here, that is int a is equals to 3, after that int n is equals to 5. Now let me save this before call my function, that is fast expo, and I am printing the value, whatever the value that will get returned by my fast expo value. I am printing those values right here. Save this and run. You can see that I have manually calculated the answer before and the answer I got there and here both are same, that is my answer is 243. So this is how we will calculate the exponent, the exponential value of a given number in an efficient way. So this is a very efficient code and this is the code. You can see that this is the code you can copy in your notebook to calculate the fast expo. You can find this particular question in lead code hacker rank like this platforms, and this is an important question and this is a good question when it comes to bit manipulation chapter. Now with that being said, we have completed our bit manipulation chapter and now we will start our next chapter, very interesting and very simple chapter, that is object oriented programming. So with that being said, I will see you in the next chapter, that is object oriented chapter. So thanks for watching and I will see you in the next one.